So, dear participant, in the previous session, we have discussed about analog input, analog output, how we can use it for different applications. So, in today's class, we are going to use combination of analog input and analog output. So, both we are going to discuss over here, and that we are going to use it. So, analog input and analog output, both how we can use it, that we are going to discuss. So, let's get started. So in the previous session, we have discussed about this, that how we can write code for analog output and how we can control that PWM signal. So today we are going to talk about very important topic, that is that how you can use both analog input and analog output, and based on that you can make some project. So let's get started. So you can see the simulation of previous one project that we have discussed, that is about the analog output. You can see we are changing the duty cycle. What is happening over there when we are changing duty cycle? So we are going to get speed over there, speed increasing or decreasing. That is based on the code that we have written over there like this. 5 we are writing it, and that we can change it also with a different time interval. So now what we want to do, अभी हम क्या करना चाहते हैं यहाँ पे? So we want to control this motor using potentiometer. Potentiometer से इस मोटर की स्पीड को हम कंट्रोल करेंगे. So how we can do that? That we are going to discuss over here. So now, first of all, I'm going to use potentiometer to read the voltage. So this one is my potentiometer, and we are going to read this value. Few coding concept that we are going to discuss in today class for analog input, analog output. So first of all, we have to connect potentiometer. How we can connect it? So the ground wire, we are going to connect it like this. Then after that, we are going to use wiper. This one is output. Output wire we have to connect with A0 pin. Then we are going to use this one is 5 volt pin. This one is 5 volt pin that we are going to use it over here. Now what next we are going to do it? We are going to write code for analog read. So this analog signal we want to read it. So ये analog signal हम Arduino में read करेंगे. So for that we are going to write code. So this one is pin mode. Pin mode we are using it over here. A0, that is input. We have to write it over there, input. Then after that, over here we are going to use one variable. One variable we are going to define it, global variable, that is now we can take it voltage in type. Int is a data type. So you can take voltage, and then you can use semicolon. So now this variable I'm going to store value in the voltage. So we have defined global variable. So no need to define again that integer or data type. Directly we are going to use voltage. And in this variable, we want to store the value, whatever value we are reading from potentiometer to this Arduino board. So we are going to use over here analog read. R should be the capital. And then after that, we are going to use over here, that is the pin number A0 pin. We are going to use it. So the voltage is equal to analog read A0. Then after that, what we are going to do, we are going to print that value on the serial monitor like earlier we have done for analog read. So serial dot print, and you can see that value. We are going to print voltage value. Whatever value will be stored in the voltage, that will be get printed on the serial monitor. Then after that, Whenever we have to print on the serial monitor, we are going to use over here, that is serial begin. Serial dot begin library, we are going to start it. So baud rate, we have to define it. So this thing that is already we have discussed. Now we are going to check it out, what output we are getting it. So as I told you earlier, whenever we are going to read any kind of analog signal, we will read value from 0 to 1023 like this. So that value should be in between 0 to 1023. But now you can see the value we are able to see over here, that is only the 0. So why it is showing 0? For that, we have to move it like this, then we will able to see correct value. But we are not able to understand that value. So what we have to do? We have to use serial print and we have to write LN. LN stand for new line, LN. Then we will able to see value in line, in new line. Now you can see. So the value we are reading it from 0 to 1023. Because in the Arduino there is inbuilt ADC that is being get used over there. So there is inbuilt ADC that is being used over there in the Arduino that we are going to use it. ADC, analog to digital converter. So we are giving 5 volt, 0 to 5 volt to the Arduino using potentiometer. So Arduino is reading in the range of 0 to 1023. So whenever we are going to write value that is in the analog output, so over there we are writing value in the format of 0 to 1023. So that value we are going to write it whenever we have to write analog output. So that is we are writing 0 to 255. 2 raised to power 10, that is equivalent to 255. So when we are going to use this one, so you can see 2 raised to power 10, that is input. So that is 1023. So whenever we are going to write analog output, so that we are going to write 2 raised to power 8, that is 256. This one is 1024, that is 0 to 1023. Total value is 1024. This one is 256 when we are going to start from the 0. So we can write 255 that we have already discussed in a previous session. Okay. So now what next we have to do it over here. We are going to read signal in the format of 0 to 1023. That signal we are going to write it in the format of 0 to 255 on analog output. Because we want to control motor speed, मोटर की स्पीड को हम कंट्रोल करेंगे यूजिंग पोटेंशियोमीटर. So how we can convert this value, because we are writing it 0 to 1023, and how we can write it over here, so that we are going to see in a code. Let's see it. So over here, what we are going to do, we are going to uh, convert this value. So this value we want to convert it in the format, or we want to write this value of voltage in analog output. So I'm going to use over here analog write, and the pin number that we are going to use it over here, any PWM pin you can use it, like 2, 3, 5, 6, 9, 10, 11. So this pin you can use it. So I'm going to use it over here 9 number pin, and we are going to write value over here, that is 0 to 255. 0 से 255 तक वैल्यू हम यहाँ पे राइट कर सकते हैं. So the value I'm going to write it over here, that is 0 to 255. So I'm going to write over here the value we are reading it. This one value directly we are writing it. This one value we are reading from the potentiometer. Same value we are writing it on the pin number 9. So you can observe what output we are getting it on the uh, pin number 9. So I'm going to use multimeter and scope and multimeter both. So that we have to mount it on the pin number 9. So on the pin number 9, we are going to mount it negative in the ground. This one we have to connect it with the 9 number pin, and you can make any different color. So same connection we have to do with this one. So the ground we have to connect with the ground, and this 9 number pin we are going to connect it with output of this scope signal pin that we have connected it over there. Now what we are going to do, we are going to start simulation and going to check it out what is happening. So we are reading value from the potentiometer and we are writing to pin number 9 from the code. So as we will rotate the potentiometer, my output speed will vary. You are not able to see on the scope, so I'm going to change the division. So make it microsecond so that you can see it clearly over there like this. So what we are doing on and off like this, and we are getting average output voltage that we have discussed earlier about the analog output. Now what we are going to do is we are going to rotate potentiometer, duty cycle is increasing. So then after that again we are increasing it. Now duty cycle is close to 100%, that is approximate 4.42 volt we are getting it. But potentiometer we have rotated only 25%. Yes, we are going to rotate it. So yes, this one is approximate 100% duty cycle in the 25% of potentiometer rotation. As we are going to rotate it, it will again zero. Why it is so? Because as I have shown you in the code, that whenever we are writing value, we are reading value in the format of 0 to 1023. And we have to write value in the format of 0 to 255. So whenever we are going to write value like this, so what is happening over there? We are rotating potentiometer. When we are going to rotate it over here, so the value we are going to read it in the Arduino, that is 0 to 255. Then it will be more, and at the end we are going to get it 1023. So when we are writing that same value, like voltage value that we are writing on pin number 9, so when we are going to reach over here, so it will give output that is 0 to 5 volt. So after 255 value, again it will start from the 0 and it will goes to 5 volt. Again repeat the same process. But if you want to control that, you are going to rotate potentiometer 0 to maximum, and your speed will also, that should be 0 to 5 volt. So we are going to use some conversion. So we are going to use one function over here that is known as a mapping function. We are going to use it. That is a mathematical function, map. So over there, what we are going to use in the map functions, we are going to convert the value. So which value you want to convert it? So I'm going to convert this voltage value. So that voltage value that we want to convert it. So this voltage value we are going to convert it. So in which, first of all, we have to define the voltage value range. So my range is 0 to 1023. So we have to use comma over there, and the range goes to 0 to 1023. Then after that, you can see the range that is 0 to, this one is the conversion. So conversion we want to do it 0 to 255. So this one is my formula that I have used over here, mapping conversion. So over there, we are going to convert this value. This one value range is 0 to 1, 0 to 3. And that value we are going to convert it in the range of 0 to 255. So using this function. So this one we are going to implement in the code. Now, when we are going to rotate potentiometer 0 to maximum, अभी हम पोटेंशियोमीटर को 0 to maximum लेके जाएंगे, तो आपकी आउटपुट वोल्टेज क्या होगी, कोड में लिखा जाएगा 0 से 255, और आपके आउटपुट वोल्टेज मल्टीमीटर पे होगी, दैट इज 0 to 5 volt that we want. So how we can use it in the code, that is the conversion that we have used. Now I'm going to see that conversion. So that conversion I'm going to implement over there. So I'm going to take one more variable, that is integer, integer. So now what we are going to do, we are going to convert this value. I'm going to take one more variable, that is uh, speed. Let me take it speed. So the variable that I'm going to take it speed. So speed variable we have taken it. So in this speed variable, what we are going to do, I'm going to use that conversion. So what conversion we are going to do it over here? So I'm going to use conversion over here, that is uh, speed, and over there I want to store the value after conversion map, and in the map I want to convert the value, this one value I want to convert it, voltage. This value I want to convert it in the range of 0 to 1023, and that conversion I want, that is 0 to 255. This one I have done it. This one is the conversion. Now, after this, we are going to use this speed value that we want to write it over here in this line. I'm going to delete it from over here, and this value I'm writing it now after conversion. So in replacement of voltage, I'm writing value over here, that is speed over here like this, speed. So on the pin number 9, we are writing speed value that is coming after conversion. So we are in the speed, we are reading value from the potentiometer. That value we have converted in the format of uh, 0 to 255 in the speed. 0 to 255 mean this value we are writing it over here on the pin number 9, and we are going to get variable output voltage, that is 0 to 5 volt. So after conversion, what next we have to do over there? We are going to start simulation and check it out. So you can see the value over here is this one. What next I'm going to do it, I'm going to rotate it this one. So you can see duty cycle is increasing. Now the value we are going to put it to 50%. You can see 50% on, 50% off. So 2.5 volt we are getting it. Again, we are increasing it. Now you can see 0 to maximum, we are rotating potentiometer and the value is changing 0 to maximum voltage is 5 volt. So this one is the ultimate purpose that we want to do it, like we want to control output using potentiometer. And one more thing over there, when we are going to use this pin number 9, we have to define it over here also. Pin mode, that 9 number pin is output. Pin mode, 9 number pin is output. So that we have defined it over there. Then after that, after doing this, we can start simulation. Then also it will work in the same way. So pin mode and should be the capital. Start simulation. Now you are going to find over there that output voltage, we are changing it, that is 0 to maximum like this. So in replacement of output voltage multimeter, we are using it. I'm going to use motor so that we can control motor speed using this potentiometer. So we are going to use the motor. So this motor speed, we want to control it over here. Now like this. So now what I'm going to do it, I'm going to connect one terminal with the ground. And then second terminal that we are going to connect it with pin number 9. Like this, and the start simulation. So simulation we have started it. Now you can see motor speed is full, one potentiometer is full, one potentiometer is 50%. So motor speed will be half, that you can see it. And now you can see when it is off, motor speed is fully off, 0. So this one we are doing it. We are controlling motor speed using potentiometer. So this one is simple code. We have written it, like with the help of that potentiometer, you will be able to control motor speed. Now what you can do, you can use flex sensor also over there, and with the help of that, you can turn on the motor, you can control motor speed also, like earlier we have done with the flex sensor. So there is a plenty of sensor that you can use it for controlling motor speed or whatever you want to do it. So that also you can do it. So now as we are going to connect over here in replacement of the potentiometer. So earlier we have used one flex sensor, that also we can use it, flex sensor. So whenever we are going to use this flex sensor, so we have to use voltage divider circuitry for that. So I'm going to connect one resistance also with that to make a voltage divider circuit like this, rotate it. So this one is voltage divider circuitry that we are using it. Then after that you can connect this one with one terminal, you can connect with the ground. Let me connect this one with ground. Then after that second terminal, you can connect it with this terminal that we are going to connect it with 5 volt like this. So I connected 5 volt and the ground. Same connection like earlier we have done it. So now we are going to get output from this point. So over here, what we have to connect? We have to connect with the A0 pin. This potentiometer I'm going to remove it now. This one, these are the connection that we have done. This one is signal wire and this one is 5 volt, that is red wire. So after doing this, code is same. Now we are going to check it out. Are we able to control motor speed or not? So now you can see we are getting this much duty cycle, that is 95%. As I'm going to tilt the angle over there, what we are going to observe. So still there is no changes over there. There is no changes still over there. So what is the issue? Let me check it out. There is small fluctuation. Let me increase this resistance value 10 to, let me take it 50K. Start simulation, then we are going to change it 50K. Now you can see it. So now we will able to control motor speed. You can see now duty cycle is changing 0 to maximum and like this. So using this flex sensor, you can make any project. What kind of project you can wear that flex sensor, and then after that you can control motor speed, you can control robot, whatever you want to control it using flex sensor, that you can do it like this. Like this. So same concept we have used and code is also same, that we are using it over there, and you can see that same code we are using it. So we have used flex sensor now, and this one is working fine with that. So that is the code of flex sensor, and the potentiometer, that is same. So this one is a combined code, combined project for speed control with flex sensor. Motor speed control using flex sensor. So that we can do it, and you can save this project and code will be also get saved over there. So now after doing this, this one is one project that we have discussed, and one more thing you can do it, you can make some more interesting project using that one. So I'm going to use one more project over here, that is indicator, that we are going to make it, some indicator that we are going to make it over here. So that is very interesting project. Like as you are going to like punch something, so you are going to see your energy level. So how much harder you are going to punch, you are going to see energy level accordingly. 10%, 20%, 30%, that you are going to see it over there. That is one thing. Okay, that project we are going to build it. That is very interesting. So might be have seen on the uh, Instagram or the Facebook in some malls, those kind of things is being deployed. You are going to punch it harder, and you are going to see your more energy level over there. So now I'm going to show that energy level using LEDs and the indicators. So we are going to make that project. So I'm going to create new one, circuit. So now we are going to use force sensor. With the help of that, we are going to measure the force. So how you can measure force? You can find over here force sensor. This one is a force sensor. You can take it. And now this one is also resistive type sensor. So whenever you have to use this resistive type sensor, what we are going to do it over there, we are going to use over here, that is a voltage divider rule, like earlier we have discussed. So we have to mount over here one resistance like this. Earlier we have used with the flux sensor. Circuit will be same. So जहाँ जहाँ भी हम वोल्टेज डिवाइडर रूल का यूज करना है और रेजिस्टिव टाइप सेंसर है आपका, सो यू कैन यूज फ्लक्स सेंसर. हाउ यू केम टू नो कि आपका सेंसर रेजिस्टिव टाइप है? यू कैन गो टू द डेटा शीट ऑफ दैट पर्टिकुलर सेंसर, sensor manufacturer detail. So they will let you know what is the type of the sensor. Then you can go to your microcontroller board like this. So now what next I'm going to do over there, I'm going to connect the sensor with the Arduino like earlier we have done it. So for that, I'm going to connect over here, that is connect it with 5 volt. This one we are going to connect it with ground. So that we have done it like this, ground and 5 volt. Black and black is the ground and 5 volt is red color wire that we are going to take it. So now that we can do it over here using this one. So now we are going to get output from over here. This output signal we have to connect it over here with the A0 pin. So that A0 pin we are going to use it for the signal wire. Signal, and you can select that one is yellow color or orange color. So this one is a force sensor connectivity. Now we are going to see the output. So we are going to connect LEDs over there. LED brightness you can control it like that, or motor speed also you can control it. So let me show with the motor speed, or you can use multiple LED also you can use it. So let me use simple one LED and their brightness will be different. When the force will be higher, brightness will be different. So I'm going to connect over there ground, and I'm going to connect one resistance over there like this, and that I'm going to connect it with pin number 12, and this value I'm going to take it the resistance value. Let me select it. So this resistance value also you can change it. I will change it later on. Now the code will be similar. You can go to the text code. So in the text code, we are going to write code for analog read like earlier we have used. Same code I'm going to repeat it. So I'm going to take two variable over there. One is integer, and the variable we are going to take it integer, and the name of the variable is force, punch force we are going to read it. So you can use a semicolon. Then after that, we are going to store value in this variable. So we can use, first of all, we have to define type of pin, pin mode. Two pins we are using it over here, A0, that is as a input. And then after that, we are going to use over here, pin mode. Another pin we are using for the output, that is 12. So not 12 number, only PWM pin you have to use it. Let me take 9 number. 9, 10, 11, any pin you can take it. So 9 number pin we are going to take it over here is a output. 9 number pin is output. Then after that, we are going to write code. This code we are going to write it over here. So we are going to use over here the variable that we are going to use it. One is, both are global variable. One is punch and second is energy level. Energy. Name is also integer energy. So the punch, what value we want to store it, how much force that we are going to apply it. So value we are going to read it analog, read in which pin, that is A0 pin that we are going to use it. A0 pin that we are going to use it over there. Then after that, what next we are going to do it over there, we are going to convert this value in the format of 0 to 255 value. So we are going to use over there the function, another variable, that is energy, and over there we are going to store value, that is first of all we are going to map it like earlier we have done it, map functions. So this value we want to convert it, so we can write over here punch, and this one value range is 0 to 1023, and I want to convert it into the range of 0 to 255 like this. So now you can see whenever now this value we have to write it on the pin number 9. So we have to use analog write pin number, we have to use it 9 number pin, and the value we are going to write it this energy value, whatever value is stored in this variable, this value we are going to write it like this. Then we are going to use semicolon, and after that you can use some delay if you want to use delay. Small delay you can use it over there. So delay I'm going to take it, that is 1 second delay. And also we have to print it on the serial monitor. Serial dot begin, and over there you can use the baud rate, and you can use semicolon. Now you can print the value. You can use conditions like 10%, 20%, 30%, 80%, how much energy are you having in the format of percentage. So I'm going to use over here if conditions, and if my value of this punch is based on this punch value of punch is whatever value we are reading it, first of all check it out what value we are reading it. Okay, first of all let me print it, serial dot begin energy semicolon, and over there we are going to print the value serial dot print. I want to print the value of punch, what value we are reading it. Based on that we can make conditions, or what we can do based on this energy value also we can make a conditions. So let me print this value directly, what value we are reading it. So this value where we are printing it, we are writing ln for new line, and this if condition we are not using right now. Start simulation and check it out on the serial monitor. What value we are reading it? 255, mean fully on. When the value there is no punch, it is showing 255. When we are punching it, so different force we are going to observe it. Based on this force, you can make your conditions. At fully force 100%, we are getting 138. So we are going to use condition over here based on this. So you can make your own customized code based on your requirement. So when the value is, sorry. So now the condition we are going to use it over here, if conditions, if the value of energy is greater than, less than, energy is less than equal to 140. So in this condition, what you want to print on the serial monitor, you can print on the serial monitor, serial dot print, and you are going to print, whenever you have to print only the value or only the name or some keywords over there, so you can use a double quote, and I'm going to print over here 100%. Anything you can print it over there. So 100% I'm just writing it. So another condition I'm going to make it, else if this condition not satisfy, so what can be the energy value? Energy value is in the range of energy value is less than equal to, let me make it 200. So when the energy is less than 200, and you can use double and over there, and again you have to use this one, energy is less than 200, and that should be greater than 140. That should be greater than 140. Because earlier we have used condition. Na? So if the energy value is greater than 140 and less than 200, so what we want to do, your energy level, I'm going to write it over here 50%. Energy level serial dot print. We are printing those value on the serial monitor, or you can use LCD over there. Serial dot print, and the value we are going to write it over here. That is double quote. You can use over here 50%. So different value you can use it over here. Right now I'm using it this one. You can use ln over there if you like. Then after that, this one is third condition also we are going to use it. Then directly you can use else conditions. If that is not satisfy condition, or if they, okay, no, not else, so you can use else if value is so the if value is greater than 200. One condition is greater than 200. Value is greater than 200. So I'm going to take it greater than 200. So what we are going to get over there? We are going to get over there serial dot print, and over there is 10% only. So different value 10, 20, 30, 40, that also you can make the condition based on the punch value or force value. So this condition we made it over here, and one more condition we are going to make it only the else conditions. So in else condition we want to print over there serial dot print. We are going to use serial dot print, and over there I'm going to write punch order. Okay, if the value is not satisfying with any conditions. So this condition I made it. Now we are going to check it out. If there is any error, that also we can troubleshoot. So there is some error. If we are starting this bracket, else if this one is semicolon. Then after that, we can check again if there is any error, that we can troubleshoot it further. Else, and unqualified ID before else. So this one is okay. We have not used this one. In else we have used over here. We have used verify it. So whatever error you are going to observe at the end of input, this one is one error. This one. This else we are using it. One more break. Since we have to use it like this. So that we have to take care, that we have to resolve the error if there is any error. So now it is working fine. You can check it out on the serial monitor. So it's printing this one value also. This one we don't want to print the value. So 55, let me remove serial print energy. This one. Only the value that we want to print it. Okay, so now start simulation. What we are going to get printed on the serial monitor. So it is saying 10% only, and the value is 255. So now when this one is at fully on, when it is fully off, you are going to see there is no force, only 10% it is shown. As you are going to punch harder over there, so energy is increasing over there. You are going to see your energy level will be higher like this. So value is 155, 165. Let it increase further. Yes, 50% now you can see it. 50%. If again you are punching with very slowly, so that is 10%. Again harder you are punching it, 50%. Again, you are punching it with full energy. So this one is 100%. So this one is one project, and you can see LED brightness will also change. Let me make this value 220 or 150 or 100. Now you can see over here when we are going to change this value like this. So you are going to observe this value will also vary, the light intensity value. That will very small over there, like when the value is over here 0, 10%, mean you are going to see LED full brightness. That brightness also you can make it inverted reverse. That we will do it later on. Now you can see LED brightness get reduced, and you can see this one is 100%. You can make it reverse also. LED brightness would also increase, or multiple LED also you can use it. So LED indicator also you can use it over there. So in that way, what you can do over there, you can make a punching press machine over there. As you are going to punch harder, you are going to see your energy level. So that can be get displayed in different locations. So that is a very wonderful project idea, and very funny also, entertaining also, that that you can make it. Punching energy level. In the same way, you can make it for running like that, and many other project also you can make it based on that, like this. So the project is being get saved, and this one is very simple code we have written it over there. So the logic will be same. Whatever complex code you are going to make it, it will work like this. You should know the basic concept, that how it will work, how we are going to rotate it, I mean how we are going to make the conditions, like if condition, else condition, how those conditions are working. If you know the conditions, then it will work fine over there. So that you can do it with that. So in that way, you can write your code and you can run your conditions. Very simple code we have written, and very simple and interesting project we made it over there like this. So that value you can display on the LCD also. In next class, we are going to talk about the LCD display. Over there, we are going to display temperature value. We are going to display like whatever value we are printing it over here in the serial monitor. That value we can print it over there on the LCD also. 10% it fully, 100% like this. So is it clear to everyone? ये समझ में आया सभी को how we have to write it? Yes and no, you can give your response in the chat box. Is it clear to everyone? Okay, that's great. That's great. So today we have discussed about very interesting project. Over there we are going to use analog input and analog output. Both condition we have used, and that we have written in the code also. And based on that, many project you can make it over there. Analog input, analog output. That is one project idea that I shared with you. Many more you can make it. One more project you can make it. You can use mic sensor over there, and based on that you can run the pump. Mean as you are going to south with the high volume, your pump will throw more water over there. Mean water level will be higher. More you are going to south, more will be the water level. Any fountain you can make it that can go higher and higher when you are going to south it. So project code will be same. You have to use mic sensor, and you have to use pump over there. So higher will be the sound intensity, higher will be the RPM of the pump. So in that way you can make it. Okay. So is there any doubt? So Vidya, I think you are having a doubt. You are not understood. So what is the doubt over there? So you can ask your queries. You can type your queries. What is the doubt? Dinaneshwar Vidya. So is there any doubt, or is it clear to you? So this one is one project that we have discussed, and we have repeated previous session also, like analog input we are using it, analog reading we are doing it in the code. I'm repeating that code again. We have taken two variable, both are global variable. That's why we have defined both the variable outside of void setup. And now you can see we are using pin number 9 and A0. A0 pin we are reading the sensor value for sensor, and 9 number pin we are using analog output pin, that is PWM pin. PWM means analog output in a simple way. So first of all, we are reading value from the analog pin. This value we are reading it. This value we are reading it in the format of 0 to 1023. So that value we are going to convert it in the format of 0 to 255 using this function. This one is a mathematical function. So you can write your own mathematical function also. That also you can write in the code. That is by default function in the Arduino library. No need to write your own customized code. That is available. You can use that one. Then analog write 9 number pin. You are going to write whatever value you are converting it. So over there you are writing value in the range of 0 to 255 like this after conversion. So then we are using conditions. If the value of energy whatever we are getting it over here in the range of 0 to 255, if the value is 140, we can write 100% output. If the value is less than 200 or more than 140, then the 50%, and at the end, if the energy value we are reading it over here, that is more than 200. Energy level is less, but the value is more than 200 because we have written code in that way. Okay, Vedya, is it clear now? So the doubt is being get cleared, or still the doubt is there? Okay, so we are going to sum up this session over here, and we have discussed very interesting project. So you have to practice it little bit on your computer. अगर आपके पास कंप्यूटर है तो उस पे आपको प्रोजेक्ट बनाना है ये, और अगर प्रोजेक्ट कंप्यूटर नहीं है तो आप अपने मोबाइल पे ट्राई करना. अदरवाइज यू कैन ट्राई लेटर ऑन व्हेन यू आर गोइंग टू ज्वाइन द कॉलेज. कॉलेज आप ज्वाइन करोगे तो कॉलेज में भी आप प्रैक्टिस कर सकते हैं. इट्स नॉट नेसेसरी कि आपको यहीं पे प्रैक्टिस करना है और आपको असाइनमेंट बनाना है. Assignment is a complimentary, or that is not compulsory. So, okay, thank you so much. We are going to sum up this session over here. Thank you so much.